Hi everyone, welcome to the new lecture in the series of number system course. And if you haven't watched the previous video in this number system course, you can check it out through the link in the description box or by clicking the I button. So today we will talk about decimal to hexadecimal conversion. So hexadecimal numbers are used to represent a large binary number in a shorter and an easier form. They are commonly used in programming, memory addresses, web callers, and computer system. So let's discuss what are the method of decimal to hexadecimal conversion. So we have to divide the decimal number repeatedly by 16. Unlike we are doing repeatedly division of 2 in a decimal to binary conversion, and in a binary decimal to octal conversion, we are repeatedly dividing by the 8. But here in decimal to hexadecimal conversion, we will repeatedly divide it by 16. And we'll write its remainder. And if the remainder, so this is the most important thing you need to know in this decimal to hexadecimal conversion. So if it is 10, 11, 12, 13, 14, 15. Yeah, you should know this much only. So 10 means A, 11 means B, 12 means C, 13 means D, 14 means E, and 15 means F. And now you should read the remainders from bottom to top. So let's see one example. One example should be cleared everything. So we should convert 26 to hexadecimal. To convert 26 to hexadecimal, we repeatedly divide 26 by 16, such as 26 divides 16. The quotient will be, here I will write a quotient and here I will write remainder. So the quotient will be, let's move it here. Yeah. So the quotient will be 1 and the remainder is 10. 10 means what? I just now told you 10 means this A. So we'll put A over here in the place of 10. Then we'll divide 1 with 16. The quotient will be 0 and the remainder will be 1. So now we'll read from the bottom to top fashion. So 1A. So 26 10 equal to 1A, that is base 16. Right. So now we will convert 255 to hexadecimal. So to convert 255 to hexadecimal, yeah, B, C, D, E, F. Yeah. To convert 255 to hexadecimal, we'll repeatedly divide it by 16. So by divide 16, the quotient will be, and the remainder. The quotient will be 15 and the remainder is also 15, means F. Now will 15 divide 16, the quotient is 0 and the remainder is 15, divide F. And now we should read from bottom to top fashion. So our answer will be FF, and this is a base 16. So in hexadecimal counting continues counting from 0 to 9, and after that we use alphabet such as A, B, C, D, E, and F. So instead of writing 10, 11, 12, we write A, B, C. So now we'll try some question. So 254 base 10 to 16. To convert this, we will repeatedly divide by 16 like this. So we'll get 14, and again by dividing we'll get 15. So instead of writing this as a 14 and 15, we will write as E and we'll write F. So in a bottom to top fashion manner, our answer will become FE, base 16. Okay. Now this is a special case. Just we are doing in a decimal to binary and octal conversion, we are multiplying with 2 and 8 respectively. Here also we will multiply it by 16. Okay. So we'll only take this particular digit 0.625 only. Okay, so 0.625 into 16, we get 10.000 and much. And for the sake of the rule, we'll also multiply 16 with 0, and obviously the answer will be 0 only. And that this is not 10, we'll write in the alphabetical order, so A. And we'll now convert this 25 into the hexadecimal form. So 25, 16, 1, then 16, 1. So sorry, it is 9. So our answer is 19 point A, base 16. So this is how you should do hexadecimal form. So hexadecimal numbers provide a compact and a human-readable representation of binary data, making them extremely important in computer science and programming. Hope you understood how to convert decimal into hexadecimal conversion. Let's move forward to our next lecture.